Before the equations of Maxwell, there was the intuition of a bookbinder. Michael Faraday, the electric boy, didn't see numbers, he saw fields, while others stared at wires. Faraday visualized invisible lines of force curving through the dark, unifying magnetism, electricity, and light. From this humble candle's glow to the massive turbines powering our cities, Faraday's mental maps became our physical reality. He didn't just study the universe, he showed us how it was stitched together. Poverty didn't silence Michael Faraday, it sharpened him. Born to a struggling blacksmith, he lacked the formal schooling of the elite. No trigonometry, no calculus. At 14, his university became the London bookshop where he apprenticed. He didn't just bind the world's knowledge, he consumed it. Between the leather covers of Conversations on Chemistry, a self-taught genius was born. Faraday proved that while math is the language of science, curiosity is its heartbeat. A gift of meticulously bound notes opened the doors of the Royal Institution. Sir Humphrey Davy hired the bookbinder to clean vials, but Faraday was destined for more than chores. Handling deadly nitrogen trichloride, Faraday risked his sight for science. But as his brilliance eclipsed Davy's, the chemistry turned toxic. The mentor became the accuser, charging Faraday with plagiarism. In the lab, explosions are a risk. In history, ego is the true volatile element. For Michael Faraday, science was a form of worship. Guided by his Sandemanian faith, he believed the universe wasn't a collection of accidents, but the unified handiwork of a single creator. While others saw separate phenomena, Faraday sought the interconnectedness of all things. If God is one, then his laws, light, gravity, and power, must be one. To Faraday, the laboratory was a cathedral, and every discovery was simply reading a page from a book already written by God. 1821. The world was powered by muscle and steam, but Michael Faraday saw a different future. While others noted that electricity could move a compass needle, Faraday asked, can it move forever? By plunging a conductor into liquid mercury, he achieved the impossible, continuous rotational motion. This wasn't just a lab toy, it was the world's first electric motor. Faraday had successfully converted electrical energy into mechanical work, setting the wheels of the modern world in motion. Political exile can be a catalyst. Pushed out of electromagnetism by Davy's shadows, Faraday retreated to the Royal Institution's basement for a decade. He didn't just wait, he revolutionized. He isolated benzene and gave science its vocabulary: anode, cathode, and ion. Most tedious of all was his work on heavy optical glass, a failed project that seemed mundane at the time. But in science, nothing is wasted. These basement years forged the tools that would eventually allow him to prove the connection between light and gravity. 10 years after the motor, Faraday delivers his masterpiece. He discovered that magnetism doesn't just exist near electricity, it can create it. But there was a catch. The magnetic field had to be changing. By toggling the current in coil A, he induced a pulse in coil B. This iron ring was the world's first transformer. Faraday had cracked the code of induction, providing the blueprint for every power station on Earth. The age of the grid had begun. Within a single decade, Faraday solved the puzzle of the modern world. By manipulating the great triad, electricity, magnetism, and motion, he birthed the three pillars of technology. First, the motor, turning current into movement. Then, the transformer, inducing power across space. Finally, the generator, turning physical motion back into a steady stream of electrons. This is the hardware of civilization. Every time you flip a light switch or charge a phone, you are using a legacy forged in Faraday's basement. Even geniuses stumble in the dark. In 1831, Faraday's peerless intuition met its match: three-dimensional space. Without formal math, he struggled to describe how motion, fields, and current intersect at right angles. He actually got the direction backward in his first paper, a rare contrary mistake. Faraday could see the invisible, but he lacked the language of vectors to prove it. It was a humbling reminder that while a picture is worth 1,000 words, sometimes you need an equation to find the truth. 1836. Science saw electricity as a flowing fluid, but Faraday saw a force. To prove it, he stepped into a 12-foot cage and unleashed a storm. As lightning lashed the exterior, the charge redistributed, canceling the fields within. Inside, there was only calm. Faraday didn't just survive. He proved that electricity lives on the surface of its conductor. This Faraday cage remains our ultimate shield, protecting everything from delicate electronics to the very aircraft we fly. 1845. Faraday's ultimate unification hunt reaches its climax. Using the heavy glass he'd perfected during his basement years, he attempted the impossible, illuminating a magnetic curve. He passed polarized light through the glass across a powerful magnetic field. The result? The light rotated. For decades, the elite dismissed Michael Faraday's lines of force as mere imagination. He had the vision, but not the calculus. Then came James Clerk Maxwell. He saw that Faraday wasn't just dreaming. He was right. Maxwell translated Faraday's sketches into 4 elegant equations, proving that electricity, magnetism, and light are a single shimmering wave. Faraday provided the soul. Maxwell provided the syntax. Together, they unlocked the code of the electromagnetic universe. Michael Faraday never patented his inventions. For him, science wasn't a path to profit, but a public good. He spent his final years applying his genius to the world's messy realities. He improved maritime safety with electric lighthouses, investigated industrial coal dust explosions, and fought to clean the polluted Thames. His most enduring legacy? The Christmas lectures. He brought the chemical history of a candle to the masses, proving that the light of knowledge belongs to everyone, not just the elite. Fame offered him a knighthood. He chose to remain plain Mr. Faraday. The Royal Society offered him its presidency. He refused twice. Michael Faraday didn't work for titles or gold. He refused to patent his world-changing discoveries, ensuring they remain the property of all mankind. Even in war, his ethics were ironclad, famously rejecting the British government's plea to develop chemical weapons. He died as he lived, guided by a love for science that no amount of money could buy. Michael Faraday's story didn't end in 1867. It lives in every wire, every wireless signal, and every electric heartbeat of our world. Einstein kept Faraday's portrait on his wall for a reason. He was the man who replaced matter with fields as our fundamental reality. From the humble bookbinder to the architect of the electric age, Faraday proved that a mind fueled by curiosity and integrity can illuminate the entire planet. The lines of force remain. The light stays on. History is a relay race of giants. When Albert Einstein sat in his study in Berlin, crafting the theories that would redefine time and space, he wasn't looking at the mathematicians of his own era. He was looking at Michael Faraday. Faraday's lines of force were the seeds of Einstein's general relativity. Faraday taught us that space isn't empty. It's a medium for fields. Einstein took that vision to its ultimate conclusion, that gravity itself is the warping of that very field. Einstein said, "I stand on the shoulders of Faraday." He made the greatest change in our conception of reality since the time of Newton. From the bookbinder's apprentice to the father of the atomic age, the thread remains unbroken. Faraday saw the field. Einstein proved it was the fabric of the universe itself.